Alright, we're here to do some quick fundamental theorem of calculus in action examples. Okay, we'll start with the blue one on the left. We got the definite integral from 1 to 3 of 2x plus 3 to the fourth. So the antiderivative is not too tough at this point. We're going to apply the power rule backwards, I guess. We're going to balance that 5 out with a 1/5. The argument gets carried through. And then remember, we have this inside 2 that we have to balance out with its reciprocal. And again, we can use this kind of shortcut, I guess, because the derivative of the inside is a constant. We have 1/10 2x plus 3 to the fifth. And we're going to evaluate that from 3 to 1. So we're essentially going to substitute in these values 3 and 1 and take the difference. And that's our fundamental theorem. So we've got 1/10 of 2 times 3 plus 3 to the fifth minus 1/10 2 times 1 plus 3 to the fifth. And when we simplify this, we'll have our answer. So we got 6 plus 3 is 9 to the fifth. I should have thought about how large these numbers were going to be. Minus 1/10 times 5 to the fifth. And so I don't have a calculator on me, so maybe you can check for me, but we're going to have 1/10 times 9/5, 9 to the fifth minus 5 to the fifth, whatever that relatively large number is. All right, let's go over here to the second one. We've got a integral with 4 functions in it, and I chose this one because I wanted to remind you that you can rewrite this integral as kind of 4 separate integrals. The 4 sine x, the tangent x, the cosine x, and the integral of 4. And then with all these, we need to have our our dx's in here to make it formal. And get a little sloppy. And then all of these, have our negative pi over 4 to pi over 4. And as we carry this through, just because we're lots of attention to detail here. Sorry if I'm rushing. It's Game 7 right now, the Cubs in the World Series, and so it's commercial break, so I got to get back to that. You should probably be watching that too. It's part of history. Anyway, what's cool about some of these functions is, you got a sine graph with an amplitude of 4. You got a tangent graph. You've got a cosine graph and a 4. But I want to point out these first two because both of these are odd functions. And so the hint here when you're learning all this the strategies is when you have this negative pi over 4 to pi over 4, you're going to have kind of a balance here where both of these integrals actually go to 0. And so all we really need to worry about calculating is the rest of this. And so because these first two end up being 0, so don't have to waste our time doing the fundamental theorem. So what I'm left with is 3 times the integral of cosine x from negative pi over 4 to pi over 4. And we've got plus the integral of 4, negative pi over 4 to pi over 4. And so let's try to crank out these antiderivatives. The antiderivative of cosine is sine of x, evaluated from pi over 4 to negative pi over 4. And again, we kind of have a 3 that's along for the ride here. And then we're going to need to add, we have the antiderivative, which would be, forget our dx's here. Our antiderivative would be 4x, evaluated from pi over 4 to negative pi over 4. And so if we finish this up, we've got sine of pi over 4 minus sine of negative pi over 4 plus 4 times pi over 4 minus 4 times negative pi over 4. So be careful with your signs here. Just kind of finishing this last piece off. I have a pi, and then I have another pi. So it looks like I have kind of a 2 pi here. And we got some unit circle stuff going on. Sine of pi over 2 is rad. Excuse me, I misspoke. Sine of pi over 4 is rad 2 over 2. Sine of negative pi over 4. I'll do a little picture up here. Negative pi over 4, you're looking at this position. And sine is negative. So we kind of have a negative rad 2 over 2. We have a 3 out here. And so I've got 2 rad 2, because this becomes a plus, over 2. And then that's times by 3. And so let's wrap this puppy up. We got 3 rad 2 plus 2 pi after all that. So, all right, thanks for watching, and have a good night.